Ladies and gentlemen, good evening. So tonight we're going to look at Spring Boot and how to use the producer to actually place some messages on a Kafka topic. So that is the situation right now. It's actually the job of the producer is actually more important than people actually think, and that is because in a Kafka setup we have something called partitions, and those partitions can be spread on. They can spread among multiple Kafka brokers, and the Kafka broker is just a Kafka server. So here we can have one partition 1 right here, and then we can have a second partition right here. And the reason why we want multiple partitions for a topic, so that means that all of these partitions right here, right now, those are within topic mic or whatever we figure out right here. So topic mic. And the cool thing about having partitions is that those can be placed among different brokers, and that means that then we can actually scale infinitely almost, because then we can also have multiple consumers, and we can have something called a consumer group. So let's say that we have an application right here. This is our Spring Boot application right here, and that is a consumer. And if you want to, then we can just start one instance up, and then the instance can then be connected to all of these partitions that we have over here. But we could actually also have multiple instances of our application. Then those could actually have a connection to one partition each. So that is why partitions are very important. And when you start a new topic, then you can create a new topic, then you can decide how many partitions that you need. So of course, in the beginning, if you don't think that the load will be that high, then you can just start with one partition, and then when you can see that that some of your performance metrics start showing that this is not a good idea, then of course you can also change the number of partitions right here. What is important is that let's say that we have a Spring Boot producer that actually produces message to the topic. Then the key is very, very important. So a message has a key and it has a value. So there's a key and there is a value. So the key could, for instance, could be like some devices that has some information. That we have a value right here. So we have a key that could be like a radiator in the basement, or radiator, temperature in the basement, and moisture in the basement, and then we have a temperature in the living room, and maybe temperature in the bathroom, etc., etc., etc. So you have all of these devices. Then, if that is your data, then that is definitely your key. So then you will have a device ID, which should then be the key. The reason why the key is very important is that if you are applying a key to your message, then all of the messages with a certain key will then go to the same partition. So let's say you have a thermostat 1, then all of the messages with the T1, they would then go to the second partition up here. And the reason why that is quite cool is that then the consumers would then get all of these messages out in ordered fashion. If you don't provide any key, then you would just get all of these messages spread all over the partitions. So if you don't give it, and it would just use a round robin strategy to do that. So the producer is quite important. It's quite important that you think about which key should be used for your setup. Of course, this is just for multi-partition topics. If you only have one partition, then you are not in the situation right here. But you should always create your code. So when you need to scale up, then you don't have to go and also change the key, the logic that uses the correct key. If you have a key which makes sense already to begin with, of course add that key to all of your messages. Okay, so enough talk. So we have one or more consumers, and when you have multiple consumers from the same client, then that is called a consumer group. So this will be a name called a consumer group right here, and each instance is a consumer, a Kafka topic consumer. So let us go to the code right here. I have a Kafka. I have a Kafka instance in my Spring Boot application. It's running right down. And when I start up my Spring Boot application, then I have configured it to automatically create a topic for me right here. Right now, I'm just going to use one partition for this demonstration right here. I'll create another video where we try to play with multiple partitions. But in this one right here, we just have one partition. I'm just going to show you how to produce a message from Spring Boot. Yeah, and I still have my Kafka stream set up from last time. That means that I'm using Kafka stream to actually handle these messages right here. Kafka stream is extremely good if you need to transform or if you need to handle your data in a specific way, then it can give you exactly once updates, because the offset is only set whenever the message is handled correctly. The offset is not set for each message or for each piece of data. You don't talk about messages when it's streaming. It's more like pieces of data. So I still have the streaming set up. So that is our consumer right here. We have a stream consumer right here, and then we have and then we have the producer, which is right now it is my first of all a configure right here. So if you don't know how to set it up, then you have to create a Kafka producer just like this, and then you have to set some properties. Those properties, of course, should come from your application properties down in the resource folder. Then it should be specific to each of your environments. But right now I'm just running locally, and it's just a demo, so I always have these properties right here. But you create some properties, and then you can create a producer based on those properties, and then you can return that producer, and then we have that bean inside the Spring Boot context. A Spring Boot context is just a huge bag of beans that are instantiated and that you can wire in wherever you want to in your application. Remember that. And then we have something new right here. We have the Kafka controller. So let us create a new package actually named producer right here. So now we have a producer, and I will just drag in my controller, and I will drag in my configuration right here, because I'm actually using a REST controller to produce messages with. So that means that I'm taking up actually it's a get mapping right now. It should be a post mapping. So let us take a post mapping right here. And the message right here, of course, that should not be, we can message and key. We also need the key, right? So we get some kind of message in, and we also would like the key. So let us just create a piece of data right here. So we should always try to create types when we want to do. This could be IoT, Internet of Things, device information. So we have some device information right here. We have some kind of device ID, and then we have maybe we have a name. We don't want a name. We want an integer. It could be temperature. Yes, temperature is a good idea right here. And then we could have that's it. So we just have the temperature, and we will just say data. Yes, let's use Lombok data right here, and all args constructor and no args constructor, so that it can be serialized. Okay, so we want one of those, and we will just remove message from the path variable. Then we will have a request body instead, request body, and there we will say, please receive an IoT device. And here we are creating a producer record. So we're creating a producer record right here. And what we want to send is, first of all, we want to give the topic, and here we have the key. The key is very important, and in our situation right here, it should not be null or some random value. It should be we need the device ID right here. So get device ID here, because that means that if I suddenly scale up to multiple partitions, then all of the messages with the same key, those will be placed on the same partition, and that means that then my consumer will get all of these messages in the correct order. Yes. And then we have the message right here. Of course, we could just spam. We could just send. We could actually send the whole device message right here as a message. That is actually okay. But we should actually have a string. We want a JSON string instead, so we will create a new object mapper right here. Object mapper, and then we'll say write as value as string. We'll get the message right there. And then we will add an exception to the methods, because we don't care about that right now. Of course, we should try and catch that and handle it in a nicer way. But it should, so that means that if you don't get, that's actually okay. That's okay right here. Then we return okay when we're done. And then this is our REST controller. But I'm going to cheat a little bit, because I have already created a test that auto-wires this controller in. So it says right here we say send a message to topic, and then we say new IoT device. It should actually be IoT device message. So let us change that. Device 1. and then we send apples taste great, or that is the temperature that let us. The temperature is then 21 degrees right here, and we need to handle the exception now, and then we will say, please rename the IoT device to IoT device measurements. So we'll go up here, measurement. So now we have a now we have a test that we can run. So first of all, we can spin up our application, and if we don't already have if the topic does not exist inside our Kafka broker or inside the cluster of Kafka brokers right there, then it will automatically be created because I have this create topic on startup right here. And here I'm using the Kafka admin to do this. The Kafka admin can do a lot of cool things, and one of them is to create or modify a topic. So that means that if the topic is already there, then it will just modify it. So that means that if it's created with one partition and you want to change this to multiple partitions, then it would just modify your existing topic to have multiple partitions. Quite cool, actually. So, and of course, your application need to be allowed to actually do this. Of course, we will talk about security in another episode. Okay, so we create the topic if it does not exist, and then we start consuming messages. So let us just do that. So Kafka application, and then run, and then let us see what happens. It is building, and then it's run when we are done with that. And while we're waiting, I can just show this beautiful drawing once again. Partitions for a specific topic. And of course, you can have multiple. You can have as many topics as you want. And how many partitions can you have, Mike? I think right now the limit is like 2 million or something like that. But actually, there are no limit. But there's no limit. But I think a practical limit would be like 2 million partitions. So it is really, really scalable. That is also why Kafka is so popular. So let us see right here what happened now. So what are we doing now? Yes, we are connected and there are no errors actually. So let us try to send a message, and we do that by running our test, and our test is right here. Here we have it, the Kafka REST test right here. Instead of just sending one message, and let us send two then. So we are sending two messages right here, and I am creating a Spring Boot test. I don't need my web environment for this test that I'm running right here, so I set that to none. That means that then I will not get any port conflict with the running application, and that means that then I can just run my test right here. And then we will see what happens in the application. If we go to Spring Boot application, oh, what happened there in Spring Boot? We got the messages in the Spring Boot application. Wow. Very, very nice. Very nice, very nice. So, let us just see where they are. So the temperature was device 1. Right here, received messages, device 1. The temperature was 21, and then it was 23 just after that. That is pretty cool. Awesome, awesome, awesome. Yes. So very impressive. That was actually, that's actually how easy it is to use the producer. Remember the key, that's the only thing, and you have to set up the configuration, and it could, of course, you could use the same configuration setup that you also use for your stream, if you both need to be a producer and also a consumer, which is quite likely, and it's also a very normal situation. Then, of course, right now I have a stream configuration right here, and you can see the server is actually the same as, the Bootstrap servers are the same, of course. And so you could actually reuse the same configuration if you want to, and then you can steal it from the application properties, of course, or the application.yaml if you're using YAML instead. Here we have the configuration for that's for the administration. Yeah, so we actually have three times. We have the configuration 3 times right here. So we're setting up a Kafka admin right here. Then there's also something called a Kafka admin client, but that is for another episode. It's not for now. So we have the Kafka admin, we have the Kafka admin client. Both of those are useful in different ways. Then we have the Kafka producer, which is good at producing messages on a specific topic with a given key. And that's why you need to think about the keys there. If you're using more than one, or if it's important. Of course, you can also say it does not matter. You don't care about which partition it goes to. Then you would just have null as the key value. Yeah, and then we have the producer configuration right here, and of course, all of these can be. There are a lot of properties right here. We will go into those in another episode also. But you can reuse the configuration. So you said you have a list of Bootstrap servers. When you have a Kafka cluster, then you don't need to mention all of your Kafka brokers in your Bootstrap servers right here. You just need to have some of them, and so you know that at least one of them will be up and running, because then it would actually get all of the information about all of the other brokers. That's how it works. So you don't need to have. Maybe your application does not know about 3 new brokers that was created and set up somewhere. But as long as you know about some of the running brokers, then they will actually tell you that which servers or brokers are up and running. So so it's also a very dynamic setup. You just need to know about at least one running server right here. And it is also okay that 2 or 3 of them are down, and as long as just one of them are up and running, it will just try them, and then it will communicate with the one that is actually up, and then it will get all of the information about the whole cluster and how it works and which brokers are up, etc., etc. So that's quite cool. It's really it's a really good product and a really good it's a really good piece of tech. It makes your application much more robust and resilient. Of course, you can also use some of the other clouds, like some of the other messaging systems, like RabbitMQ is also really good. It's also really fast. There's also the message systems in the clouds, like in Asia and AWS and GCP. In Google, it's called PubSub messages, and the other clouds they have something like that also. And those are also really, really fast. Remember to think about your Backoff strategy. That is a common mistake to make. That now you're up and running, your application is working, you're happy, but then you forget about the your Backoff strategy, and at some point you will make an error that will actually create an exception or something. So your application breaks or stops. Then you don't want the message to be handled right away again, because then you can actually you would end up in the same situation. Your application will fail once again, and then you will get this infinite loop that can cost you a lot of processing in the cloud, and it can be quite expensive. So remember to have a Backoff strategy, and it should be exponential with a maximum. You can have a maximum, for instance, of 10 minutes, and then it will exponentially back off. So first it will try a rate of maybe 1 second, then 2 seconds, then 4 seconds, then 8 seconds, etc., 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 until it reaches 10 minutes, and then it will each message will then wait 10 minutes before they are trying to be before they will be retried. That is how it works with the messaging system. With Kafka, we have something called an offset instead. So that means that every time we are done processing a message, not every time, but when we're done processing some messages, then we would actually tell the partition, or the broker, that now we have actually seen these messages up to offset maybe 110 or something like that. And then if our application breaks down and we start up again, then we will not get all the earlier messages than 110. It will not happen for each message. It will happen for after some messages, and that is actually, I think it's also configurable somewhere. That's what I want to show you. The code is available on my GitHub account as usual. Feel free to take it and use it if you can. Have a nice purpose for it. And else, it's a cool topic. It's a lot of fun. I really enjoy making these videos. Thank you for all of your comments, and I hope to see you again very soon. Bye-bye. And have a great evening. Bye-bye.